Hi everyone, welcome to Ms. Sawagid's math class. Last lesson, we learned about relations and functions. We learned a relation is a function only if every input has exactly one output. We also learned that an ordered pair can represent a relation with x and y as an ordered pair, where x is the input and y is the output. Today, we will learn the different ways of representing a function. How can we represent a function? So let's start with something easy and we use every day and we enjoy watching movies. If you want to go to the theaters and buy tickets, if each ticket costs you $10, how much does it cost a family of 6 to go watch the same movie? Mental math, we all know that. $10 times 6 people gives you $60. So the total cost is $60 for those 6 people. So can you write an equation that gives the cost, but this time we're not using x and y, we're using the cost C for any number of people n. So n represents the number of people and the C represents the cost. Can we write the equation using C and n? So C equals 10n. The total cost equal the cost per ticket times the number of people. So the cost depends on the number of people watching that movie. Because we are discussing functions, let's take this equation, C equal 10n, and discuss each term or each letter in that equation. C is the cost and n is the number of people. The cost is the output. The output depends on whatever the input is. So n is the input, which is independent variable. So the cost, which is the output, depends on the number of people input watching or buying the movies. We write it as an ordered pair, n and c, instead of x and y, where n is the number of people and c is the total cost. Here's another new vocabulary words for you for this lesson. It's called function rule. What is a function rule? Function rule is an equation that describes the relation between the input, which is the independent variable, and the output, which is the dependent variable. So a function that relates the x and the y, or the input and the output. Write a function rule for this example. So if I'm asking you to write a function rule, that means you are writing an equation. It says the output is half of the input. So each word represents a number or a symbol in math. The output is the y, is means equal, half literally is a fraction of half, of means time, and the input means the x. As an equation, write it down, y equal half x, nothing in the middle because it's multiplying. That's called a function rule, which is the equation. Here's another example. The output is 3 less than the input. This time, watch the word than, and I will tell you why. The output, which is y, is means equal. Now, do not start with 3 less. Circle than and start with whatever comes after than. And it does make a difference. The input, which is x, then go back and say 3 less means minus 3. Why? Because when you subtract a number, for example, 4 minus 3 equals 1. But 3 minus 4 equals negative 1. So the order does matter. That's why when you see that, circle it and start with whatever comes after that. Now, number 3, the output is 1 more than twice the input. The output is y. Is means equal. Again, then circle it. Twice means 2 times the input, which is x, so 2x. Then go back and say 1 more plus 1. Now, in addition, it does not make a difference, or there does not make a difference. But so you don't make that mistake when you have a subtraction, just start with whatever comes after that. The function rule, or the equation that represents number 3, is y equal 2x plus 1. Now, here's something you already know about. Evaluate the function. We just changed the name. It's the same as evaluate the equation for the missing value of the variable. Example number 1, y equal x over 4 plus 5 when x is 2. So they're giving you the value of x. All you have to do is substitute it in the equation and find the missing value of y. So y equal 2 over 4 plus 5. Simplify that. 2 divided by 4 is half. So you end up with y equal 0.5 plus 5. Add the 0.5 plus 5 gives you y equal 5.5. So you just evaluated, which means you found the value of the missing variable. Second example, y equal to 3x minus 8. Again, this is a function or an equation. All they did today is change the name. Instead of an equation, they named it a function. When y equals 1, make sure you substitute the right variable with that number. So this time you're substituting y with 1. So you end up with 1 equals 3x minus 8. I need to isolate x with the addition property of equality, because if you add the same number on both sides, the equation stays equal. So negative 8 plus 8, they cancel each other. You end up with 9 equals 3x. Still, x is not isolated. I need to get rid of the 3. Since it's multiplied by x, the inverse operation is the division. So the division property of equality states if I divide both sides by the same number, the equation stays balanced. So if I divide both sides by 3, 3 divided by 3 is gone, so it was 1. And 1 times x is x, so x equals 3. Now, let's write an equation that describes the function. So I'm writing a linear equation for this table that relates x and y. I will leave that table that shows how to find the slope and the y-intercept different ways. One of them is from a table. So to write the equation y equal mx plus b, I need to find the slope from the table and I need to find the y-intercept from the table. So how do I find the slope from a table? The slope, which is the m, equal the change in y divided by the change of x. So we need to find out how did y change, which is delta 1. How did y change from 6 to 4 to 2 to 0? It went down by 2, so that's subtracting 2. Now the change of x, how did x change from negative 3 to negative 2 to negative 1 to 0? It went up by 1, so that's adding 1. So the change in y is negative 2, the change of x is positive 1. Simplify that, the slope equals negative 2. Now I need to find the y-intercept, and the y-intercept is the value of y when x equals 0. Did they give you that in the table? Yes. Watch how when x equals 0, y also equals 0, so the y-intercept or the b equals 0. All I have to do is replace the slope and the b or the y-intercept in the equation. You end up with y equal negative 2x plus 0. Anything adding to 0 stays the same, so y equal negative 2x. Write an equation now from a graph. Still, the table shows the way to find the slope and the y-intercept. So the equation is y equal mx plus b. We need to find m, which is the slope. We need to find b, which is the y-intercept. But how do we do that from a graph? To find b, it's where the line crossed the y-axis. Where did this blue line intersect the y-axis? Right on 6. So b equals 6. Now I need to find the slope, and the slope is the rise over run using a graph. This time I am going to use this for first point at the 6 on the y-axis, and then here's another dot on the line. Now we're going to do the rise over run. We can go up and left, but since the line is dropping down, I am gonna go down from 6, and make sure you're counting by ones, so go down from 6 to 4, so the rise is negative 2, and the run from 0 to 1, that's only 1. So you're dropping negative 2, and you're running only 1 time. So the slope, when you simplify that, equals negative 2. Replace the slope and the y-intercept in the equation, so y equal negative 2x plus 6. Let's solve this word problem. It makes more sense. A dolphin eats 30 pounds of fish per day. Write a function that relates the number of pounds P of fish that a dolphin eats in a D days. So we're not using X and Y. We are using different letters, but still they are variables. P represents the number of pounds, and D represents the number of days. To write the equation, it's P equals 30, which is the rate of change, 30 pounds per day for every day, which is D. Which variable is dependent and which variable is independent? P, which represents the number of pounds, is the output. Therefore, it's the dependent variable because the number of pounds a fish eats depends on the number of days it passes. D is days, which is the input, so that's independent variable. A rule of thumb, time is always independent variable because time always passes. Whether it's in seconds, minutes, days, years, it doesn't matter. It's always independent. And whatever we do in that time is dependent, which means it depends on how the time passes. Just a rule of thumb. How many pounds of fish does a dolphin eat in 30 days? Now I can use the function that I already wrote down, P equals 30D, but make sure to replace 30 days, since they've given you the number of days, replace the D with 30. So, and finding the number of pounds. So P equals 30 times 30 is 900 pounds. So the dolphins will eat 900 pounds in 30 days. In conclusion, functions can be represented different ways. One of them is mapping diagram, and this is how the mapping diagram looks like. Another one is graph that relates the X and the Y value in the graph. Equation also shows the relationship between the X and the Y. Input-output table, any kind of table that has X and Y, or the input and the output. Or even words, just like the beginning of the class, we said the output is half of the input as an example. We turned it into an equation, or even word problems. We turn them into equations and solve them. That's it for today's lesson. You guys have a great day.